Hello everyone, my name is Jonathan Harper. I'm a Senior Solutions Architect at Contrast Security. In today's session, we will be discussing contrast metadata, including application metadata and session metadata. We'll start off discussing application metadata. We'll explain why it's useful, how to implement it, and how to use it, as well as showing a demo of this in action. We'll then move on to session metadata, following a similar pattern of explanation. We'll then discuss when to use one form of metadata or the other and summarize what we've learned. So let's go ahead and get started with application metadata, which we'll use to organize, find, and understand applications we are onboarding into the Contrast platform. We'll start off with some definitions. Application metadata is a series of one or more key value pairs that helps uniquely identify applications when using the Contrast UI or APIs. Application metadata is used for metadata that does not change or very infrequently changes between application builds or runs. It is an optional but useful feature for various filtering operations in both the Contrast UI and Contrast APIs for purposes such as dashboard report filtering, applications filtering, identifying and contacting an application owner or team, or pointing to other application relevant information such as source code or documentation. The application metadata is especially important to implement when you're trying to do large-scale deployments, as it can become difficult to know all applications without having the additional context this data provides. It is also helpful when security teams do not interface closely with the development teams, so it can be hard to know who owns what resources within the environment. It is also very helpful when you are trying to generate reports based upon geographic, organizational, or other boundaries that you've defined using this metadata. Having the ability to dissect the data using application metadata can help determine areas within the organization that may benefit from activities such as focused training. Now that we've talked a little bit about why application metadata, let's jump into how to implement application metadata. There are a few steps needed to get started. First, a Contrast administrator will need to determine and set the desired metadata fields within the Contrast UI. The field definition is not available to normal Contrast users. Second, when a user onboards an application, they will need to use the Contrast UI to define values for each of the metadata fields. If the desired metadata is available within the pipeline, this collection step may be automated instead. Third, the user onboarding the application will download a YAML configuration file that includes key value pairs for the defined application metadata. If automation is used in the previous step, this configuration file should be automatically generated, or you can optionally use an environment variable at deploy time instead. Last, the configuration file will be used when starting the application, adding the defined application metadata to the application within the Contrast UI. Now let's show some examples of this. Here we can see an example of the definition step where we define several required fields. Again, this requires administrative privileges within the Contrast UI to define this list. After this is completed, users will be able to view and fill out values for each of these fields. Once that step is complete, we can move on to the second step where the user will define the specific values for each of those fields. On the left, you can see an example of that, where during the configuration step, users are prompted for values for each of the defined fields from the previous step. On the right, you can see the resultant YAML configuration file that was downloaded after filling in the values from the custom fields. We'll start off our demo by adding our desired custom fields within the Contrast UI. To do this, we'll navigate to the menu in the upper right-hand corner and select Organization Settings. Once that page loads, we'll click Applications on the left-hand side. Under the Custom Fields section, we can add our desired custom fields. The field type can be freeform, numeric, or point of contact. Most fields should fall under the freeform type. You can choose to make it a required field, specify whether or not it is unique, such as with an internally recognized application ID. You can also add additional fields here if you desire more than one. If you'd like contrast agents to be restricted from sending data to the platform unless they have the required fields set, you can enable this option. It can be applied to only new onboarded applications or all applications, new and existing. I'll go ahead and fill in some of the form fields now. Now that I've entered the desired fields, we can scroll down to the bottom of the screen and see that the agent configuration section has been generated. This can be copied and placed within the contrast security YAML file, adding in the appropriate values for the specific application. Additionally, users onboarding their application will now be prompted for this information when onboarding a new app. When I click the Add New button at the top of the screen, I am now prompted to fill out this information for my agent configuration, which I'll do now. After filling out all the required fields, you'll be able to download a YAML file, which will include a section with all the key value pairs for each of the custom fields. Let's go ahead and open that now, and here we see all those values that we filled out. Once we start the agent with this configuration, we will be able to see and use the metadata within the contrast UI and APIs. I've gone ahead and onboarded an application using this configuration. Let's explore how this metadata is displayed and used within the contrast UI. Application metadata can be used within the contrast dashboard to filter the data displayed within the widgets on this screen. We do this by clicking the filter icon. You'll see that we now have sections within this filter dropdown that allow us to select specific values to apply these filters to our reports. Additionally, if you prefer to get this data via an API call, you can apply the desired filters and then click the cloud icon within a widget to see the API call, which includes the selected metadata filter. Another place within the platform that uses application metadata is the applications list view. Like the dashboard, we can apply filters to only list the applications we are interested in. Additionally, if you select a specific application, you will now see the metadata key value pairs populated at the top of the screen. So let's move on to session metadata, which we will use to organize, find, and understand vulnerabilities and route coverage within the contrast platform. Let's go ahead and define what session metadata is. So session metadata is a list of key value pairs that uniquely identifies the source of vulnerabilities and route coverage information from within an application. Unlike application metadata, session metadata is usually used for metadata that changes between builds or runs. It allows filtering of vulnerabilities by this metadata within the contrast UI, such as by the build number, the branch name, or the application version. You can also use this metadata to query the contrast route coverage and vulnerability APIs. Since we are a continuous monitoring solution that can be deployed to multiple environments simultaneously, session metadata can be important for implementing correct feedback loops, such as security gating within a CI/CD pipeline or during a pull request. So now that we know what session metadata is and why we would use it, let's talk a little bit about how to implement session metadata. Since session metadata uses dynamic values, it should not be entered manually. You will want to automate the collection of the values during the build stage and use those values during the application deployment. There are two main options for setting these variables. You can use the contrast application session metadata environment variable, or you can use the equivalent configuration setting within a dynamically generated YAML configuration file. Collection of the data will differ depending on the build system in use, but will usually come from predefined environment variables coming from your build system. For example, with Azure DevOps pipelines, there are many predefined variables available, which can be used to collect information such as the source code repository branch, the build number, and the repository URI. This is not exhaustive, and there may be company-specific variables as well that are defined here that you may want to use. Once the data is collected from the build system, it can be used to populate the contrast YAML configuration file or the contrast session metadata environment variable passed to the application at runtime. Now let's demonstrate how this works within Azure DevOps. Looking at the Azure DevOps documentation, we can see that there are many predefined variables that we could leverage for session metadata. For this demonstration, we are going to use the build ID and the branch name, but you could also use others from this list. Jumping over to my pipeline definition within Azure DevOps, you'll see that during the build stage, I'm simply creating a file that contains the contrast application session metadata environment variable with the values set to the build ID and the branch name using the environment variables that we chose. This file is then used during the deployment to a test environment where we are setting that within the environment. When the application starts with that environment variable set, the session metadata values will be associated with all vulnerabilities and routes detected. To see this, we can go over to the Contrast UI, navigate to our Applications tab, go into our application, and then go to the Vulnerabilities tab. Here we can select what information is displayed within the right-hand column over here, as well as filter by that data and choose either branch, build, or both, and determine what vulnerabilities are shown within this view. In today's session, we discussed application metadata and session metadata and demonstrated how to use each of these. Let's wrap up by summarizing what each type of metadata is used for and comparing them. Application metadata is used for organizing, sorting, and filtering data at the application level. The data specified for application metadata should not change frequently, if ever. Some examples of data that should be specified via application metadata are the name of the application or an application ID, application description, the name of the company, the business unit responsible for the application, the team developing the app, or the source code location. Session metadata, on the other hand, is for data that changes very frequently, often after every new build or release. It is used for organizing, sorting, and filtering data for vulnerabilities, as well as for route coverage. Some examples of data that should be specified via session metadata are in the environment that the application is running in, the build number of the app version, or the branch name. Thank you for watching. We hope this discussion about metadata was very helpful for effectively deploying contrast at scale. Please let us know if there is any feedback or if there are other deep dive topics of interest.